So back to method 24. This is going to be another video about like a limit. This is going to be on 2.2 to 2.3, which is a concept of the limit and the computation strategies. So it is method 24 between 2.2 and 2.3. Section 2.2 to 2.3. It is like a limit and like a limit computation. Actually, first of all, what is a limit? And so we define like as like a limit as x approaches to a of a function f of x equals to like a limit. So it's like as x approaches a, its limit is L. So, and then the limit is L. So the output is just f of a. It is closer to L. For example, here we have a function this 2, 4, here's a graph of f of x. And if we do x equals to 3, and what is the limit as x approaching 3 of f of x? Here we can see is when x equals to 3, the function graph it is at here, so about 5.8. So we can say that the limit x approaches to 3 of f of x, it is 5.8. But when x equals to 2, here's the challenge. You think there are just 2 in there. There's 2 and 4, and you can't just say that never average the 2 limit values here. Never average it. Or maybe take a guess. What is the limit of f of x as x approaches 2? The answer is does not exist. Or D and E. And limit exists only if the two-sided limit it is equal. to the limit are equal, then we can and we have it as a limit as x approaches a, f of x equals L, also equal to the limit of x approaches a from the left side of f of x, also equal to the limit x approaches a from the right side of f of x. All three values must be equal, then the limit exists. Let's try an example here. Evaluate the graph of a piecewise function f of x. Perhaps we have it is graph so we have draw the y-axis. Here's the x-axis. We have a point. Okay, here's the graph of f of x, a piecewise function. Question number 1. Is a limit x of f of x as x approaches 6. From here we have at 4 it is 10 defined. And f8 it is, here's the function here that f8 is 5. So compute the slope, the 5 is midpoint. F6 is on the midpoint. So we have F6 is 15 over 12 or 7.5. Question number 2. What is like the limit x up x approach x approaches 8 minus f of x. This is means like x approaches to 8 from the left side. So it's 5. Five is a limit at x approaches 8 from the left side. And number 3 is a harder one, but you will get it. What is the limit of f of x as x approaches 4? As stated before, the limit exists if both side limit exist. Is equal. That's why there exists. In this case, the limit of f of x as x approaches 4 from the left side of f of x, it is 8. And the limit of f of x as x approaches 4 from the right side, it is 10. Since the limit from left side is not equal to the limit right side. So the limit does not exist. Warning. Do not average two-sided value of limit. Never averaging them. In this case, don't be that kids. This is a that kid. This is wrong. In section 2.2, we have a graphical approach of the limit. In section 2.3, we are going to do a numerical approach of the limit. Page number 7. just in section 2.3, we will learn the limit. We learn just about, we will learn numerically. Compute the limit. Although some like a limit loss, that it is useful for this chapter. Here's some like the basic limit and loss for section 2.3. For number one, it's a constant law. The limit x approach a, and it's a constant. It's constant itself. So if x approaches 14 and 12, it's 12. No other changes. And number two, the limit of x approaches a of x itself, then answer is a. So if we have a limit of x approaches 4 of x, output is 4. Number three is like the limit of x approaches a of f of x plus g of x. It is equal to a limit of x approaches a of f of x plus the limit of x approaches a g of x. We come out here, so we have like a limit of x approaches 5 of 4x plus 10 is equal to the limit x approaches 5 4x plus the limit of f x approaches 5 10. It is 20 plus 10 30. Number four we have is a product rule. As x approaches a of h of x, the L of x, it is a limit of x approaches a h of x, and multiply by a limit of x approaches a of L of x. And then what we have it is perhaps a limit of x approaches 9 of x to the cubic is equal to the limit x approaches 9 x and multiply by limit x approaches 9 x, then multiply by a limit of x approaches 9 of x. It is 729. Number 5 is a quotient rule. Limit of x approach a it is f of x over g of x. Also, to make sure the denominator is not a 0. And then the limit, it is let's do an example here. X approaches -2, x squared 4x. We have it's like the limit x approaches -2 of x squared over limit as x approaches a -2 of 4x. It's going to be 4 over -8. It is -1/2. And now more computation strategies here. And we're going to do, we're going to introduce a multiple type of the problem that you might encounter in the future of the course. Some even part of Method 25 or Method 26. So type 1 is the most straightforward computation. It's a straightforward computation. This type of problem may be easy, so it's very unlikely to appear on the exam or the final. So never get this wrong. Those are basic problem for Method 24. Example. One, we have a limit x approaches 15 of 2x squared minus 8x plus 24. Then we apply the power rule, then we apply the product rule and sum rule and like difference rule. So the limit as x approaches negative positive 15, we add them up, you can see what I'm writing about. Sorry for making a very small mistake, but I spot them. What we have it is 1525, 450 minus 120 plus 24. It is 330, 354 is the limit. Example number 2, I should be the third example. This number is, and now will be number 3. X approaches -4 will be 2x squared minus 4, 2x plus 1. Compute the limit. The bottom is not a 0, so let's roll. We'll put -4, 2x squared minus 4 over the limit x approaches -4, 2x plus 1 is equal to -16, 32 is 28, -4, -7, so it's going to be -4. It's the limit. Number 8. Should be type number 2. This involves the polynomials. They're factorable, so we call them factorable polynomials. This type of problem, usually I even find a whole, all the term can be canceled. Cancelable term, or the whole discontinuity, or asymptote. The polynomial can be factored. Let's do an example here. This type of example may be like the easiest on the exam, as long as you have algebraic work. So this is like not hard for you if you pay attention, you know how to factor an equation or polynomials. 4, like the limit x approaches 6 of x squared minus 36 over 2x plus 12 and that's a minus 12. Now, if you can see, just the plus 16 is a 0, bottom is also a 0. So this type of this type of limit we call is like because it's like a 0 and a 0 limit. Factor the polynomials. Factor the numerator and the denominator. And then the first step we will get it is the limit x approaches 6. We factor them. And we see x minus 6 is the cancel term because if plus 6 then it's a 0. Remove the singularity. Then we have is this, the limit x approaches 6 over x plus 6 over 12 is still 6. Our final answer is 6. Another example. X approaches negative 3. It's going to be this one is just harder. Try it on your own. Perhaps it's just on the actual midterm. Again, you're responsible for taking the exams, not me. Then you have to learn the stuff. And let's factor the numerator. X plus negative 3 is still a 0 limit. We have it is x plus 3, x plus 5, x plus 3, x minus 3. Cancel the term x plus 3. And we have is the limit x approaches x plus -3 is a -3. Is -3. It is x plus 5, x minus 3 is -6, -2, going to be like a -6, +2, and -6, so it's going to be -2/3 is the final answer. So number 6, let's do another one. Limit x approaches 4, absolute value sign x minus 4, x squared plus x minus 20. This is another one. Pause the videos and then try down on. Perhaps it is on the exam. So this is a two-side limit. So this is a two-side limit. For from the left side should be negative, inside should be negative. So should it be 4 minus x over x squared plus x minus 20. We have is like a limit for left side, negative x minus 4 over x minus 4 and x plus 5. We remove the singularity. We have for minus a -1 over x plus 5. It is -1 over 9. And the right side, x minus 4 squared plus x minus 20 is equal to, we factor them. Five will be limit of x approaches 4 from right side, 1 over x plus 5. It is 1 over 9. Since two side limit are not equal, then the limit does not exist. Not equal to plus then the limit does not exist. Wow, it's 40 minutes. So I'm just gonna pause here and I will pick up the rest of section 2.3 on my next video. Thank you guys for watching. Have a good day. Very good day.